Assalamualaikum to Madam Shada and Miss Hikmah. Uh, my name is Madihi bin Norhadi. I will present the introduction for Lab 2, which is mud viscosity and other rheological properties. Okay. So, rheology is the study of how matter deforms and flows. The rheology of drilling mud is one of the important things that is needed by engineers. So mud rheology is measured on a continual basis while drilling and adjusted with additive or dilution to meet the needs of the operation. So properties such as viscosity, gel strength, and yield point are some extremely important mud rheology for the selection of the drilling mud. So viscosity is a measure of the resistance of a fluid which is being deformed by either shear stress or tensile stress. So the property of gel development is related closely with the flow of the drilling fluid. The gel that are used tend to be thicker when the operation is being stopped, or the operation or the circulation of the mud is being stopped. So when the gel become thicker, it needs to be break, and the power that must be obtained, and the power that needed to break the gel is the gel strength. Okay. So the value of the gel strength is important for the engineers because it will be used by the engineers to make decision on how the mud pressure is selected and used for the drilling operation. Okay. So now we are moving on to the objective of the experiment. So the first objective of the experiment is to determine the viscosity, gel strength, and yield point of each of the sample that will be used, which is the oil-based mud and the water-based mud. That is for the part 1 of the experiment. For the second objective of the experiment, it is to measure the funnel viscosity of drilling by using marsh funnel, where the sample that used are only water-based mud. Oh yeah, and also the oil-based mud.
For the theory part, as we know that viscosity is a measure of the resistance of a fluid which is being deformed by either shear stress or tensile stress. It is measured as the ratio of the shearing stress to the rate of shearing strain. In this experiment, the viscosity was measured by using baroid viscometer. Gel strength is a function of interparticle forces. Gel strength was measured by using the baroid viscometer in unit pound per 100 square feet. First mix the water-based mud will under 600 rpm for 3 minutes, then rest for 3 minutes, then mix again under 3 rpm. The first reading deflected was taken as the gel strength reading. Yield point, which is YP, is a resistance of initial flow of liquid or fluid or the stress required in order to move the fluid. Simply put that the YP is the attractive force among colloidal particles in the mat. Yield point can be calculated by using this formula, which is YP equal the reading from a viscometer at 600 RPM minus by reading from a viscometer at 300 RPM. A unit of YP is pound per 100 feet square. In water-based mat, the YP will be increased with following items, which is high temperature, where the high temperature environment tends to increase the YP in the water-based mat. Contaminants such as carbon dioxide, salt, and anhydride in the drilling fluids. Also, overtreatment the drilling mat with lime or caustic soda. For apparatus and material part, for part A, which is for Rheological determination using viscometer, we use baroid viscometer with mat sample, water-based mat and oil-based mat. Also a mat mixer. For part B, which is determination of marsh funnel viscosity, we use marsh funnel with receiving cup, mat sample, which is water-based mat and oil-based mat. Also a mat mixer.
Alright, next procedure for this experiment. Basically, there are two parts in this experiment, which are part A and part B. For part A is a mud rheological determination using viscometer. So in this part, there are three experiments, which are viscosity, gel strength, and yield point. Alright, for the first, viscosity, step 1 is test fluid is stirred at low speed for 5 minutes by using the Hamilton pitch mixer. And next, the drilling fluid is then poured into the sample cup to the level corresponding to the predetermined both length. Alright, next, with drilling fluid in the cup properly placed in the viscometer, the rotor sleeve is immersed exactly to the script line. Alright, next, the test fluid is sheared at 600 RPM until the top reading reaching a steady value, after which the stabilized dry reading is recorded in descending order at 600 RPM and 300 RPM. Alright, last, each dry reading is recorded before changing to the lower speed. Alright, next experiment is gel strength. So, first step is oil-based mud is stirred at 600 RPM about 1 minute. And next, allow the mud to stand in undisturbed for 1 minute. Then switch the RPM node to 300 RPM. Next, the maximum reading is recorded. Alright, the last one, repeat the step for water-based mud. Alright. The last experiment for this part is yield point. So first step, the dye reading of water-based mud is recorded at 600 RPM and 300 RPM by using fan viscometer. Then the yield point is calculated by using the formula as follow. Alright, the reading at 600 RPM minus the reading at 300 RPM, and that one is a yield point value. Part B, which is determination of marsh funnel viscosity. So first step, the marsh funnel is covered with a finger in an upright position. And next, 500 mm of oil-based mud is poured through the screen until the mud exactly reaches the bottom of the screen. The finger is removed immediately from the outlet and the time required is measured in seconds by using a stopwatch. So the reading in seconds from the stopwatch is recorded as a funnel viscosity. Alright, next, the experiment is repeated with the volume 400 ml and 300 ml. And the next, the number of seconds is reported as funnel viscosity. And the last, change the mud to water-based mud and repeat the same step. Alright, next slide is result for part A and part B. So for part A, there are two results. So first one is result of viscometer for oil-based mud and water-based mud. So from the table, you can see that the value of plastic viscosity, yield point, and apparent viscosity is more higher for water-based mud compared to oil-based mud. So for plastic viscosity, the value of plastic viscosity for water-based mud is 2 centipoise compared to oil-based mud, which is 0.5 centipoise. And the value of yield point for water-based mud is 35. It's more higher compared to oil-based mud, which is 4.5. And the apparent viscosity for water-based mud is 18.5 centipoise, which is more higher compared to oil-based mud, which is 2.5 centipoise. Alright, the next one is the result of gel strength for water-based mud and oil-based mud. So from the table, from the result, we can see that the value of gel strength for water-based mud is also higher compared to oil-based mud, which is for water-based mud is 45 and oil-based mud is 12. Alright, next, part B. So as we can see, the result of for part B, the average time for water-based mud is more higher compared to oil-based mud, which is the average time taken for water-based mud is 38 seconds. It's more higher compared to oil-based mud, which is 27 seconds. Alright, next, this slide will show the sample calculation for part A and for part B. So for part A, since there are three values that need to calculate, which are plastic viscosity, yield point, and apparent viscosity. So for water-based mud, to calculate the value of plastic viscosity, the reading at 600 rpm minus reading at 300 rpm, which is 37 centipoise minus 35 centipoise, and equal that 2 centipoise. That one is for the value of plastic viscosity. And the value of yield point, the reading at 600 rpm minus plastic viscosity, the value we get from first calculation. So 37 centipoise minus 2 centipoise, and we get 35 centipoise. And the last one is for apparent viscosity, the reading at 600 rpm, divide 2, and the answer is 18.5 centipoise. For next slide is the calculation for oil-based mud. The calculation is same with the water-based mud. And next slide is part B, determination of marsh-finial viscosity. So there are two types of muds, water-based mud and oil-based mud. So for this part, the calculation involve for average time. So since there are three different volume, so plus and divide 3 to get the average. For water-based mud, we get 38 seconds, and oil-based mud 27 seconds.
From the experiment that we had conducted, based on all the result and all the calculation that we had done for water-based mud, the viscosity for 100, 200, 300, and 600 rpm are 30, 31, 35, and 37 centipoise respectively. The plastic viscosity is 2 centipoise, while apparent viscosity is 18.5 centipoise. The gel strength is 45 centipoise, and the yield point is 35.35 pound per feet cube. For oil-based mud, the viscosity for 100, 200, 300, and 600 rpm are 2.6, 3, 4.5, and 5 centipoise respectively. the plastic viscosity is 0.5 centipoise, while apparent viscosity is 2.5 centipoise. The jet strength is 12 centipoise and the yield point is 4.5 pound per feet cube. Primarily, all drilling fluids, especially drilling mud, can have wide range of chemical and physical properties. These properties are specifically designed for drilling conditions and the special problems that must be handled in drilling aware. The purposes of drilling fluids include cooling and lubricate the drill blade. Besides that, it also removes cutting from the well. Moreover, it controls the pressure to prevent blowout. Drilling might also solve some drilling problems include lost circulation and stuck pipe. Plastic viscosity, PV, control the magnitude of shear stress developed as one layer of fluid slide over another. It is a measure of friction between layers and provide a scale of the fluid thickness. With liquid, plastic viscosity decreases with the increasing in temperature but reverse with gases. Any increase in solid content in the mud as particularly solid, low circulation material, etc. will result in higher the plastic viscosity. In order to lower the PV, you must reduce the solid content that can be achieved by using solid control equipment and or diluting drilling mud with base fluid. With increasing temperature while drilling deeper, the plastic viscosity of the drilling mud will decrease because the viscosity of the base fluid decreases. Normally, the higher mud weight, the higher PV will be. However, if you have an increasing trend of PV without mud weight change, it means that there is an increase in ultra-fine drill solid content in the mud system. Moreover, if you use oil-based mud, please keep in mind that emulsified water in oil-based drilling fluid will act like a solid and it will increase the plastic viscosity dramatically. Effective viscosity depends on fluid velocity flow pattern. It is difficult to measure but can be calculated. The J strength is the shear stress of drilling mud that is measured at low shear rate after the drilling mud is static for a certain period. The J strength is one of the important drilling fluid properties because it demonstrates the ability of the drilling mud to suspend drill solid and wetting material when circulation is ceased. If the mud has the high jet strength, it will create high pump pressure in order to break circulation after the mud is static for a long time. Furthermore, increasing in a trend of 30-minute jet strength indicates a build-up of ultrafine solid. Therefore, the mud must be treated by adding chemical or diluting with fresh base fluid. Yield point is a resistance of an initial flow of fluid or the stress required in order to move the fluid. In other words, yield point is the attractive force among the colloidal particles in drilling mud. Yield point is influenced by the concentration of solid, their electrical charge, and other factors too. If not at the proper value, it can also reduce drilling efficiency by cutting penetration rate, increasing circulator pressure, and posing the danger of low circulation.
Now I will explain and present the discussion for part B, which is the determination of marsh funnel viscosity. So for the second part of the experiment, the objective was that we must measure the funnel viscosity of drilling by using marsh funnel. So viscosity is the measurement of thickness of a fluid and measured as the ratio of shearing stress to the rate of shearing strength. Funnel viscosity is measured in number of seconds of drilling mud flowing through the marsh funnel viscosity. So, based on the experiment, which is the result, the average time taken for the water-based mud and the oil-based mud to reach the bottom of the screen are 27 seconds and 38 seconds respectively. It can be seen that the oil-based mud has a higher value of funnel viscosity compared to the water-based mud. The difference can be seen that the oil-based mud is slower and take more time to reach the bottom of the screen. This is because the molecules for both of the drilling mud can also affect the flow of mud. For water-based mud, it can flow much faster than the oil-based mud because water are bonded together as they are polar molecules, while for the oil-based mud, they are not bonded by polar molecules. Because of that, this explains why the oil-based mud takes much more time to reach the bottom of the screen than the water-based mud.
Alright, in conclusion, so the main objective of this experiment was achieved for experiment part A and part B. So the main objective for experiment part A is to measure the rheology properties of the mud sample, which is the viscosity, yield point, and the gel strength of the mud sample. And for part B, the main objective is to measure the final viscosity, and then we can compare it with the plastic viscosity that we get during the experiment. So in petroleum industry, drilling fluid is one of the crucial part in drilling operation, which is it can act as a lubricant where to cool down the bit. And then drilling fluid also used to bring the rock cutting from downhole to surface. And other than that, the drilling fluid also act as a pressure control, as it can prevent against the kick or loss of coil control. So this is a reason why we need to control the viscosity of the drilling fluid. For recommendation, so as the recommendation that can be made to improve the experimental process and achieve the experiment's objective, we need to ensure that the apparatus or viscometer are in a good condition in order to avoid any error during the experiment. Besides that, make sure that the mud is mixed properly by using a mixer or stirrer to avoid undissolved in the mud. Other than that, always check the error in reading of equipment before using it in order to give more accurate value that needs for calculation. Furthermore, in order to avoid any during calculation, make sure to repeat the experiment at least 3 times to get an average reading. Finally, please ensure that use the clean beaker before using it for the mud in order to get an accurate result. All these steps are important to ensure the most accurate result of the experiment can be obtained.